Well, thank you very much, Travis. I keep saying, you know, I'd really like to meet that guy that you described in that introduction sometime. He sounds like a great guy. All right. So I'm sure, that all of you have heard or maybe never heard before of some of these terms I'm going to bring up here, right? Internet of Things, Industrial Internet of Things, Industry 4.0, of course you have. Have you heard of the cloud? Of course you have, right? Have you ever seen a real live demonstration of the cloud? Because we are launching right here on stage our new cloud computing environment. You can see it right there in the light. Those are all bits floating around there. That's the cloud. Now you can say you've actually seen the cloud. No, that just a little joke there. So, of course, you've heard of all of these things. It's almost impossible to escape them. There are a lot of discussions about them in the media. So let's take a little look at what I think they actually mean, what they're going to mean to you as we go forward into the future in terms of what they'll do for you on the operational side. So, Steve and Roel talked to you a lot about all the great things we're doing on projects. Let's talk about how we can use some of this technology like the Internet of Things to improve operations. Now, there are actually many initiatives in Europe. We tend to hear, or at least certainly I can say in the United States, I tend to hear the most about Industry 4.0. I think it gets the most press. But this is a chart I took from the European Commission, and I don't expect you to be able to read it. I only expect you to get the takeaway that nearly every country in Europe has some kind of initiative around smart manufacturing, digital manufacturing, Internet of Things technology, all kind of tied together. We tend to hear the most, as I said, about the German one around Industry 4.0. Then, of course, in the United States, we actually have the U.S. government also getting on board with this. Now, that is not as well known or as much heard about, but what happened is the Obama administration, probably about 4 years ago, started this initiative around improving manufacturing in the U.S., and they actually commissioned something called the National Network for Manufacturing Innovation, and under that, there's going to be a number of institutes in the United States. It's actually pretty similar to the Fraunhofer Institutes that are in Germany, and they're going to target some of these areas, especially new manufacturing technologies, new materials for manufacturing, as well as digital manufacturing, or digitization as it's sometimes called. For digitization, we have actually another nonprofit coalition called the Smart Manufacturing Leadership Coalition, and Emerson is a part of that. So there are government activities in the U.S. as well as all the government activities that are going on inside of Europe. Now, we all know, though, that Americans are capitalists at heart. So where do things really happen in the U.S., right? Well, it's driven by big U.S. companies are the ones that also get out there and push technology and push the marketing of new technology. So you have all these large American companies and some European ones as well that are spending a lot of time and effort on promotion and marketing around, many of these concepts, especially around the Internet of Things kinds of concepts. And they all may have their sort of marketing name or term that they tend to use around it, and they're spending a lot of time and effort promoting this. Why? For many years we're used to, I think, in our industry of being the follower of technology that comes from the information technology arena, that they pioneer it and then we use it. Suddenly, we're kind of thrust in the forefront here with all these big IT-type companies talking all about this Internet of Things technology, and especially talking about how it's going to do all these great things in manufacturing and industry. Well, again, being good capitalists, the answer is simple. There are these studies going on around looking at IoT and IoT technology, which of course applies to many areas, right? Smart cities, smart people with sensors on their bodies, okay? Retail, smart stores with automatic inventory control. But this is one of the many studies, but this is one of the more widely used ones from a company called McKinsey, okay, a consulting company. And you can see they're saying, okay, in 2025, the impact of IoT will be anywhere from $4 to $11 trillion. But out of that, they're saying the industry or the area that will see the biggest economic impact is manufacturing. which they've labeled as factories on here. So this has drawn the attention of a lot of these big companies and a lot of these normally IT-oriented kind of companies to the idea, hey, that something big is going on in the manufacturing area with this digital technology, okay? Which, again, we're usually, we've historically been a little more of an afterthought, to be honest, to those industries, to those companies, as they've focused on kind of the IT world first. So let's just look for a minute at Industrial Internet of Things and Industry 4.0 and talk about kind of what are the concepts or what are the things that they cover. Well, first of all of these concepts have some core sort of thoughts or terms in them around this idea of digitization. Digitization of all kinds of data and the connectability of that data. And then in Industry 4.0, you also hear a lot of talk of cyber-physical systems, right? Machines and physical systems that are so instrumented that they are actually smart, they actually provide data. GE uses this term brilliant machines all the time, okay? And those are kind of some of the core concepts that go across all of this. Now, if we look at the world of manufacturing that all of us live in, and then we kind of look at the world of everything else, and by everything else I mean smart cities and smart humans and whatever, okay? Well, that's IoT, all right? IoT, Internet of Things, is in all of those areas, okay? When we look at the world of manufacturing, we actually typically talk about the industrial Internet of Things, meaning IoT technology applied to manufacturing and production type applications. When we look at Industry 4.0, Industry 4.0 really is just focused, as the name might imply, around industry and manufacturing, okay? And it includes all of those concepts, I would say, of the industrial Internet of Things, but it's also broader because it tends to look upstream into the design and order management and the integration of all of that together with some of that online Internet of Things kinds of technology, which is more focused around the operations area. So if we look at Industry 4.0 and we look at kind of the vision there for design and manufacturing integration, which is a core part of that, these are some concepts that we're not going to see so much in IoT. Okay, and I'm going to spend the majority of my time now forward talking about IoT and some of the operational technologies and things we can do. But I thought it's worth talking about, hey, there's also some very interesting concepts here around digitization, around the integration of the whole manufacturing design chain from custom order to digital design to actual manufacturing instructions coming out for the automation equipment, and the resulting in what is sometimes called the digital thread of the data, or the digital twin is another term that's used, so that you end up with a model, a digital model of what's going on that you are able to collect data on in real time, even as a real product is out in actual use, and use that data to provide feedback to improve your design for future designs. So Industry 4.0 has this whole section around the integration of the design and manufacturing, as well as that back end on the operational data collection, okay? Now, Industrial Internet of Things, really what we're talking about with Industrial Internet of Things is not that complicated. It's a very, very common concept to everyone sitting in this room. It's fundamentally the idea of feedback control applied to a whole new host of application areas. The idea that if you want to really control and improve and optimize something, what do? First, you measure it. I don't care if it's your health, your weight, okay, the energy consumption, the number of parking spaces in a garage. It all starts with what? Measuring it, seeing what's going on, getting real-time data, okay? Then running that through some algorithms, running that through analytics, and taking action. Because it doesn't do any good to collect a whole bunch of data if you're not going to actually take action on it. So it's that same fundamental concept that we've all used to control our plants and processes, okay, only applied to a host of other application areas. Again, let's look at what we've been doing for the past 40 years in the process industries with our DCS, SCADA, PLC, RTU systems, right? Sensors communicate that data over specific protocols that we came up with for our industry, ran that through software and algorithms in those systems, came out with control actions or information to an operator that they use to decide on what to do. So I jokingly call that's the Model T of the Internet of Things, right? That's the original first implementation, okay, of IoT. And some crazy company had this idea 20 years ago that maybe you would take all these smart devices and you'd put them in your plant and you'd connect them together and you'd get digital data from all of it, and you'd end up with like a web of intelligent devices for your plant. What a crazy idea, okay? So again, that was, we weren't smart enough to call that plant IoT 20 years ago. And it was constrained to your plant. It was not an Internet of Things, okay? It was a smart web of technology just inside of your physical plant. So when we look at this same concept and we apply it to today's world of Internet of Things, what do we see? Well, we see sensors basically for any kind of application, all right? So that could be energy, reliability, control, safety, whatever it may be. Data communicated over internet protocols to a host of all new databases and storage technologies, and I'll mention a few of those in a minute, okay? That data, that application can be distributed anywhere across the globe. Why? Because we're using the internet now and the universal connectivity that the internet has provided, and that means that data can go to anyone, not just somebody in your plant, but can be somebody thousands of miles away doing analysis, figuring out what to do. The applications that we're targeting now are not just the traditional process production things that we've always done, advanced control, MES, optimization, but a host of operational applications. Health, safety, security, and environmental, HSSE. Reliability, certainly the most targeted application for IoT things, the most talked about and maybe the most immediate opportunity around diagnosing equipment, predicting future states, okay? And then energy consumption, optimizing both the consumption of energy by your facility and the optimization of the generation of that energy that you may be doing yourself in-house. It always starts with data. Again, I don't care what it is you're trying to look at, you need to have data. So at Emerson, we have a strategy that you've heard us talk about called pervasive sensing, which is this idea that there will be a whole new portfolio of sensors to cover all these new application areas. They'll be very easy to install and maintain. Wireless provides a very large part of this. And just like you have it for your process, you're going to have it for all these other application areas. Let's continue with the car analogy. The exact same thing has already happened in cars. What was the first digital controls in cars? Engine management systems, run the core process, fuel injection systems. Now, sensors for safety, for braking, for maintenance and reliability, monitoring the condition of your engine, same kind of thing is what we're going to see happen in our plants. One of the ways that will show is today, in many of these areas, the way you collect the data is manually, which can be very irregular, sometimes doesn't even get put into a system. So part of our pervasive sensing strategy is to look at all those places where you have just gauges or manual collection and turn that into continuous, real-time, reliable transmission of digital data that can be used into these other applications. That data is feeding an avalanche of new technologies. I was in a conference just last week where someone said, and I believe them, they had counted 157 different platforms for IoT that have been launched or announced or talked about, over like the last 5 years. There are just all kinds of companies now springing up around big data, analytics, IoT platforms, IoT architectures. We've got our traditional ways of collecting data in the plant. There's all these new protocols, some of which you've probably never heard of, that are now IoT protocols, came out of the IT industry. All these platforms, an alphabet soup of technology. And then we have the clouds, right? So we have companies like Microsoft, GE that are saying, no, we take all that technology that you see on the left-hand side of the equation, and we have put that into a complete environment to do these applications that runs on the cloud, okay? I'm not going to talk much more about this because we could be here all day as we go through some of the different alternatives and the benefits of a particular technology. What I am going to talk about is how that's going to affect your plant architecture, no matter what technology you pick. So today, you have control systems, you have safety systems, and their job is to run the plant safety. And as cybersecurity concerns increase, you're having to guard that ever closer and put more and more safeguards and more barriers around that to keep that more secure. So as we're going to pull in all this extra data, as we're going to put in this pervasive sensing, we're going to put in all this other stuff, it's not all going to come running through your DCS. And I'm an old DCS guy. I'd love for it to come running through your DCS, but that's not how it's going to work. You're going to have a system for all those other application areas that collects that data. And then, if you're comfortable, you're going to connect that system to these cloud-based applications that I talked about before with the correct security on them. So that will be, unlike this, which tends to be very wired, robust, secure, majority over here, wireless, Wi-Fi technology, high availability, but not the highest availability like the critical system that runs your plant. Available to just about everyone in the plant because it's supporting not just the core operations application, but all these other functions in the plant. Reliability, environmental monitoring, whatever they may be. So it will have different characteristics than the automation network you have today. Here's the big thing. When you talk about the internet, and when you talk about this data being available over the internet, it introduces a whole new potential business model. So today, as Emerson, what have we traditionally done? We have sold you tools and technology and applications and software that are installed on your plant. You take care of them, you figure out what to do from the data, and you take action, okay? It's very much like you have a transportation problem and you buy a car. And you buy a car from Mercedes. That's maybe the one we'd like to be associated with as Emerson. I don't know, So what the internet does, and when you start talking about this being out on the internet, is now it opens a whole new world of, well, you don't need to be the one doing that anymore. Somebody else, like Emerson, can be analyzing that data. And we could be analyzing that data and dispatching, sending your local service provider to do something about it, or dispatching your own maintenance people to do something, or it could be all the way over on the right-hand side where it's like an outcome-based service. Where we actually see the problem, analyze the problem, and just go take care of it. And that's a business model more like Uber. You have a transportation problem, you call Uber, they pick you up, they take you where you're going to go. You own no technology, you don't own a car, You just get the outcome. You get moved from where you are to where you want to go. Is that good? Well, it's got advantages, it's got disadvantages. What are the big advantages? You don't need to have that technology. You don't need to make the capital expenditure. You don't need to have that domain expertise in your plant. What are the concerns? The biggest one has always been that I've heard, data security and privacy. The concern about data leaving the plant and data going out into someone else and what's going to happen with that data, okay? Many times those applications also need to be looked at by multiple departments in the plant in order to get the right output. One architecture we've put together that avoids the security problem, and we've deployed this in a couple of sites already. We collect the data with a separate set of sensors. We run the data over the cellular network, goes to our data center and our application guys, and they analyze it, and we have never touched your network. The only data that can go over that connection, obviously, are those new sets of sensors that we put in place. So I think this is the big question for us and for you as we look into the future. Not whether these applications are going to happen, because I'm fairly certain they're going to happen. As they become cost justified, as the business cases get proven, as the cost of getting the data goes down, you're going to do these applications around reliability, energy, these other areas. The big question is, are you going to do it yourself? Are you going to put together a monitoring center or an IOPS center, as they're called in the oil and gas industry? Monitoring center is a typical term in the power industry. Or are you going to contract? Are you going to buy a car? Or are you going to take Uber? Are you going to contract us and others like us to actually do that analysis and figure out what needs to be done for you so you don't need to have the skill sets? And there's reasons for both. First of all, I think this is the path the big guys are going to take. If you're a large company with multiple facilities, especially multiple facilities that are the same, you will likely do that yourself. You won't do 100% of it. You will still have some outside service connections for some specific equipment classes. For some specific equipment like valves or rotating equipment, you will want a best expert to look at that like ourselves. Here's an example. This is a company called Luminant Power in the US that has put one of these big monitoring centers together themselves. And this is their chart, which I borrowed with their permission, where they're looking at over 16,000 megawatts of generation in 48 different units, and they sell that service to other power plants. So that's yet another outsource model where they sell the complete service of a whole industrial facility looking at it. And they said, make sure to tell everybody to get our website because we're happy to expand in Europe. We'd love to start looking at power plants in Europe. Here's an example of the IoT world. This is where we've done it for valves, where we have a customer where we've connected up to their to their heart output on their valves, and we're monitoring the valves for them with very good results. One of the companies we're working with on this IoT service model is Microsoft. Microsoft has a very comprehensive end-to-end solution with their Azure services. And this is an example of how that would roll out as an architecture for monitoring, where we're able to give you the privacy and security concerns you're concerned about with a device in between called the data diode that basically takes that heart data, no matter how we get it out of the valve, converts it to one of the internet protocols. This is the one that Microsoft is using for messaging back over to their Azure hub, where we would run our valve services. Here's an example, a subset of some of the applications we offer in this operational area today. Most of these applications we still have in the traditional model where we supply tools and technology for you. Some of them we actually offer as just a service. You will see I believe all of these applications in the exhibition area, you'll see them in the pervasive sensing area, and you'll see them in the industry application area. And I have wellhead monitoring on there. We also have a number of others for the upstream oil and gas area. So, this is happening today. It's not that different, really, than what you're doing today. Data, analytics, action. What we're talking about is a huge opportunity for new application spaces. And we're helping that go as best we can with new sensors and new technology to make that go. And as I said, I think the big question is, you can do it yourself, you can do it as a service. Because you now have the opportunity to do that, and you haven't had that before. Okay? We're happy to help you either way you want to go. We have those applications. We have just tools and technology, if that's what you want, and you want to do it yourself. And in many cases, we have it as just a service. So enjoy the rest of the conference. Hopefully go check out some of these applications in the exhibit area and get a demonstration of our new cloud. So thank you.